Are you tired of having to constantly take measurements for your home brewing system? Are you tired of making giant messes when you're transferring liquids from one vessel to the next?
Well, then we have the solution for you. Introducing the Warthog Automated Beer Brewing System.
The Warthog consists of four main subsystems: an application and microcontroller, power, optical sensing, and instrumentation. Once the data is passed from the application to the Warthog, the brewing process begins. The valve seen here opens and fresh water fills the hot water tank. The level of the hot water tank is determined by the pressure sensor mounted at the bottom. Once the desired level is reached, the heating element located inside begins heating the liquid to a temperature defined by the user. Once the water temperature is reached, the water transfers into the meshing tun via the pump and valve seen here. Once the meshing tun is filled to the desired level, the heating element located inside retains the desired temperature throughout the meshing process. This is achieved by using a PID algorithm along with an IGBT-controlled linear power supply, which receives a PWM signal from the microcontroller. Throughout the meshing process, water is circulated by using this pump and this valve. This assures maximum sugar is transferred into the liquid, now called wort. Once the meshing process is complete, the wort transfers into the boil kettle via this valve. In addition to this transfer, more water is added from the hot water tank via this pump and valve. This addition of water assures all sugars remaining in the grain are washed and transferred into the final wort product. Once the boil kettle reaches the desired level, the heating element located inside brings the liquid to a boiling temperature. Once the liquid inside is boiling, the hop hopper located above the keg disperses hops at time intervals defined by the user. The hop hopper allows the user a total of 4 hop varieties to be added at any desired time interval. Once the boiling process is complete, the wort is transferred into a cooler via the pump and valve seen here.
The Android application is the user's main interaction with the system. The application accepts 15 input variables which are used throughout the brewing process. Each input box has an acceptable boundary range which rejects unfeasible or unsafe values. Once all is completed, these variables are sent to the microcontroller via a Bluetooth module. The application then transitions to the command page, which consists of a start, pause, emergency stop, and change buttons. Once initiated, the rest of the brewing process is completed autonomously. The Bluetooth module mounted on the microcontroller provides a range of up to 25 feet, perfect for a home brewer's garage space. If the user's phone leaves Bluetooth range, the application will automatically reconnect whenever the area is re-entered.
The power subsystem operates at 120, 208, and 240 volts, allowing the end user maximum flexibility. It consists of an AC to DC converter producing 12 volts at 10 amps. This voltage is then reduced down to 9 and 5 volts to power the microcontroller and sensoring devices. In addition, the system has 3 linear power supplies, each providing linear and controllable power to the 3 5500 watt elements. These power supplies receive a signal from the microcontroller at low PWM frequencies and generate a linear output.
The optical sensor subsystem is composed of 2 main liquid chambers where the wort will flow. The laser shines through these containers and exploits different optical effects, such as scattering and absorption and liquid-dependent reflections. These then get detected by the photodetectors and are sent to the Arduino.
The instrumentation subsystem is comprised of 2 different sensors. We have temperature sensors and pressure sensors. For our temperature sensors, we use RTDs. These RTDs produce a varying resistance with the change in temperature. We then take that changing resistance and convert it to a 0 to 5 volt output for our Arduino. Pressure sensors are mounted at the bottom of each keg so they can measure the change in pressure as the liquid level increases or decreases. They output at 0 to 5 volts for our pressure range. This output is given to our Arduino so that it can calculate the liquid level in the kegs. You can plug the Warthog into your standard 120 volt outlet and you're ready to start brewing. Here we see the mash tun filling up until it reaches its preset level value. Once the mash tun levels off, the system begins heating the water in the keg. While the system is heating the water, it circulates the water. Here we see the temperature measured by our system versus the temperature measurement made by a fluke meter. This red light indicates that the heater is being fired in the mash tun. As the system gets closer to the temperature set point, the light will begin to flash, indicating that the heater is being turned off and on. This is due to the PID control. Here we have our hop hopper dispensing butt connectors into the boil kettle at a specified time in the boil process. This is the box that contains the optical sensors and equipment. I'm about to demonstrate inserting some wart into the system, and I will show you how the Arduino picks up this change in signal. Here's the Arduino giving the current readout of the detector voltage. You can also see the attenuation decreasing as well as the specific gravity.